We are now in Module 13. We are in Module 13A. And what we're going to do today is talk about two formulas we use to describe lines. Okay, we've been working with graphing, so we're going to look at these two formulas. So if you would please go to your notes. Okay, the two formulas we're going to discuss today are called the distance and midpoint formula. And what these formulas are used for is they're words to describe a line segment. Remember, a line goes on forever and ever. That's why we've been putting arrows on it. Now we're dealing with a line segment, and a line segment has a beginning and an end, two endpoints. And if you have a beginning and an end, like from A to B, I could ask you two questions. The first question I could ask you is about the distance. Now, another word for distance is length. So if I want to find the distance between 2 points A and B, if you look here on your notes, you have this crazy formula. Okay, and to work this formula, you need to know the two endpoints. Okay, because we're going to find the distance, the length of the line segment, we got to go back to understanding basic concepts. When you drive, do you drive negative 20 miles? Are you negative 6 feet tall? No, of course not. So we know when we're finding a length or a distance, the answer's always got to be positive. Okay, what we're going to do is we're going to go up to the board, and we're going to look at 3 examples with distance. Okay, everybody. So what we want to do is, you see here I have a graph board. I know it's not the best, but it will work. And the first thing I want to discuss with you is the fact that you don't always need to use that formula for distance. Distance is a concept you could just think about. So it's important to have out graph paper. So if I plotted 2 points. So suppose I plotted point A here at 1, 1. And I plotted point B here at 5, 1. And I made my line segment. And I asked you the distance. We would not need that formula that we're looking at in our notes. Because if you have a line segment that goes horizontally straight across, to find its distance, all you have to do is count the boxes. So if I start at 1 and I go to 5, that would be a distance of 4. So if you counted, once you move your finger, 1, 2, 3, 4. We would say that distance is 4. So we don't need the formula. If I draw this other line segment, suppose I put point C here at 1, negative 2, and I put point D here at 1, negative 5, and I connect those points to make a line segment. Again, that line segment is vertical. It goes up and down. You would not need the formula to find the distance because all you could do is count. If I'm here at negative 2 and I go to negative 5, that should be a distance of 3. So watch my finger. Here I am at C, and I'm going to count. 1, 2, 3. So when you have line segments that are horizontal and vertical, you don't need to work the formula. And I'm going to give that to you as a hint because why do extra work if you don't need it? If you could visually graph it, then why don't you just use the graph? But if you look at example 1 in our notes, the points they give us are at negative 4, 9, negative 4, 9, which is all the way up here, and 1, negative 3, which is all the way there. And if you connect those 2 points, and please mind you, I'm doing this freehand, so it's not going to look pretty. But if you connect those 2 points to make the line segment, it's not horizontal, it's not vertical, it's diagonal. And on this system, which is called the Cartesian coordinate plane, you cannot count the boxes diagonally. So then we have a problem. We got to find the distance another way. We can't count. Well, your book says use the formula. So first of all, you have to memorize the formula. It's D equals square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I know you're saying that's a lot. I'm going to teach you how to memorize it in words. If you look, we're going to take the 2x values of the points and subtract them. The word for subtract in real life means change. Think about it. When you get back change from buying something, they subtract the numbers. If there's a change in the weather, you're subtracting numbers. So I memorize this as the change in x squared plus the change in y squared, because change means subtract. What we want to do is we want to take our 2 points, our 2 endpoints, which here were negative 4, 9. So I'm going to put them here. And the other endpoint was 1, negative 3. And the first hint I can give you is label each one an x and a y. So that way when you go to substitute in the formula, you don't get confused. Now, important, it doesn't matter which point you make the x sub 1 and which one you make the x sub 2. This does not mean the second x and the first x. It just means there's 2 x values. You can't write the formula x minus x, because x minus x would be nothing there. So that's why we have the subscripts. So just decide who you want to do first. I do them in the order I see them. So we write d equals the square root. We're going to fill in. My first x is negative 4. And I'm going to subtract from it my next x, which is 1. And then square it. Now be consistent. If I started with negative 4 as x, I got to start with 9 as y. So the formula says I write my first y minus my second y, which is negative 3. The most important thing with the distance formula to find the length, there's a subtraction symbol in between the 2 values you're taking away. Now you all know, according to Please Excuse My Dear Aunt Sally, to work what's inside parentheses first. So we copy the square root. Negative 4 minus 1. They're the same sign, so we add them. We get negative 5 squared. Plus 9 minus negative 3. Subtract means to change the sign. That becomes positive 3. 9 plus 3 is 12 squared. Now that we got done what's inside parentheses, we're supposed to work exponents. So you write d equals square root. Negative 5 squared means negative 5 times negative 5, which is positive 25. Remember, when we're squaring, this should always be positive. Plus 12 squared is 12 times 12, which is 144. All right? Now we all know we can't square root yet till everything's combined inside the symbol. So 25 plus 144 is 169. You should all know the square root of 169 is a perfect square. What number times itself is 169? 13. Now, because we're on graph paper, we don't call this 13 feet. We don't call it 13 inches or centimeters. We say 13 units. The length from here to here is 13 units. That's how you work the distance formula. Now think about what we did, okay? We found the change between the x values and y values. All of you young guys that have had a geometry class before, you know this formula, but you've used it with different letters. And let me explain what you have done. If you had a good geometry teacher, they would have told you, if you're on graph paper and you have a diagonal line segment, I know you can't count the boxes to find out how long it is, but you can transform that into a shape. You could drop a height straight down, and you could draw a base. And what shape did I just make? A right triangle. And you all that are young especially should know, to find the side of a right triangle, there was a special rule or theorem from a special mathematician. It was called the Pythagorean theorem. Pythagorean. And the Pythagorean theorem was from a Greek mathematician, Pythagoras. And he said if you have the side of the triangle and the side of the triangle, you could find the length of the hypotenuse. Now look, we know this side of the triangle, how long it is, because we can count. If you're here and you want to get down here, look at how many boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you want to know the base of the right triangle, you can count. Here's my finger. I'm going to move it. 1, 2, 3, 4, 5. Now I want you to look at those numbers 12 and 5. Aren't they in the distance formula we worked? Sure, 5 and 12. Those numbers are coming from the change between here and here. This x value was -4. This x value was +1. The change in that was a distance of 5. Isn't that what you took, the -4 and the 1, and subtracted it? This point's y value is at -3. This point's y value is at 9. I want the difference between negative 9 and 3, which is what you did here, which is 12. So what I want you all to notice is, if you had a good geometry teacher, you learned Pythagorean theorem was a squared plus b squared equals c squared. The leg squared and the leg squared give you the hypotenuse squared. This formula up here is Pythagorean theorem. This all here, this x sub 2 minus x sub 1 squared is your a squared. The change between the x values. Plus the y sub 2 and the y sub 1 squared is the b squared. The change in the height. And this is your c squared. But you don't want to know what c squared is, you want to know what c is, so that's why the formula is square rooted. So using the distance formula is the Pythagorean theorem. So if you know a squared plus b squared equals c squared, this is not hard to memorize. Now, the problem with math and graphing is great when everything you plot are numbers that are whole, that are integers. But there's no guarantee on this graphing system. You have to plot integers, whole numbers. You could plot a fraction, it would be in between. But think about it, guys. If I plot this point in between here, do you know it's exactly halfway in between? No. So graph paper is not a good tool if you're dealing with points that are fraction values. And that's what we talk about. Why do we even need formulas or rules? If you can't graph it and look at it, then you need a formula and rule to work it out. So let's now go to example 2. Okay, I'm going to keep the formula up there. The question for example 2 says, find the distance between, look at these ordered pairs, 7/3, 1/5, and 1/3, 6/5. Now I know what you're thinking. You're saying, I can't even plot those on graph paper. You sure can. You could plot those on graph paper, but you're not going to be able to tell the distance. And my eraser's not working here, so we'll deal with this. So if I was going to plot 7/3, because it's an improper fraction, we'd have to, in our head, convert it either to a mixed number or decimal. 3 goes into 7 twice, so that's a little bit bigger than 2. And 1/5 is a proper fraction, which is between 0 and 1. There's where 7/3 is. Okay? So 7/3, 1/5 is right there. 1/3 is a proper fraction. It's between 0 and 1. 6/5 is improper, so you have to change it. 5 goes into 6 at least once, so that's a little bit bigger than 1. That's right there. Well, if you connect those 2 points, yeah, they're going to make a diagonal line segment, but you can't look at this and tell me the distance from there to there. So we're going to need the formula. So now we get to have some fun and review some arithmetic. So we're going to label these x and y, and we're going to fill in our formula. Distance equals square root. Do not skip steps. Write everything down. I'm going to do my x's in the way I see them. I see 7/3 and 1/3. So I'm going to write 7/3 subtract 1/3 squared plus, I'm going to do the y's in the same order. 1/5 subtract 6/5 squared. Don't boo-hoo to me that you need a calculator to subtract fractions. Subtracting fractions is a 3rd grade math concept. We've already been through this. To subtract fractions, you need a common denominator. We got it. So we're going to subtract. 7/3 minus 1/3 is 6/3 squared plus 1/5 minus 6/5. 1 minus 6 is -5/5 squared. Now, if we're following, please excuse my dear Aunt Sally, order of operations, we're not done. Inside the parentheses, these are fractions. Fractions mean to do division. Can you divide? Sure you can. 6 divided by 3 is 2. That's 2 squared. Plus, -5 divided by 5 is -1 squared. Now we're going to do our exponents. We're going to square. 2 squared is 4 plus -1 squared is 1. Remember, when you square, they're always going to be positive. Now, what's 4 plus 1? That's 5. So this is the square root of 5. Can you square root the number 5? Is there a perfect square in 5? No, 5 is prime. This means the distance is roughly bigger than 2. Okay, how do I know that? Because I know something about square roots. I know I could square root 4, and I know I could square root 9. I know the square root of 4 is 2, and the square root of 9 is 3. The square root of 5 would be somewhere in the middle of that. Not exactly 2.5. Square root of 5 is closer to square root of 4. So if I type square root of 5 in my calculator and get a decimal, it's probably like 2.1 something. Remember, anytime you use your calculator and you get at a decimal that goes on forever and ever, it's called an irrational number, and you can't play God and round it. Now, if the directions say to round, go around that decimal. If they don't say to round, then you have to leave the answer in the radical form. So this is the reason why we need a formula. Okay, if we're not dealing with whole numbers on graph paper, the formula is going to get us our result. All right, let's try one more distance. All right, look at these lovely ordered pairs. The first ordered pair is 3 square root of 3 square root of 5. The second ordered pair is negative square root of 3 4 square roots of 5. Now I know what you're saying. You're saying those would never be on a graph paper. Yes, they would. We talked about this already. If you have a square root of 3 and a square root of 5, which cannot be broken down, if you type that in the calculator, you would get at a decimal that goes on forever and ever. These are irrational numbers. They're like pi. They're decimals. Decimals are located on the graph paper. They're just, you can't plot them very accurately. So to find the distance between these ordered pairs, we'd have to use the formula. So you write d equals square root. I do my x's in order. Here's my first x, here's my second x. So I'm going to write my first x, 3 square root of 3. It says to subtract, and then I'm going to write my second x, negative square root of 3, squared. Plus, I'm going to do my y's in the same order. I'm going to write square root of 5 minus subtract 4 square roots of 5. Is everybody good? Great. Now, we all know we're supposed to work what's inside parentheses first. We know two negatives make a positive. Now, we've discussed this over and over again. The definition of add is like terms. You can only add the letter x to the letter x. You can only add fractions that have the same denominator because that means they're alike. In radical or root world, you can only add radical roots when what's inside the radicand is alike. These are both square root of 3, so you can add them. There's 3 square roots of 3 plus 1 square root of 3. Well, that would make 4 square roots of 3. Remember, when you add, it doesn't change. We just did 7/3 and 1/3, and the denominator stayed a 3, a third. When you add an x to an x and you make 2x, the x stays the same. Over here, this is 1 square root of 5 minus 4 square roots of 5. The radicals are alike, so you do 1 minus 4, you get negative 3 square roots of 5. Now we have to square each of these. I'm going to go over here to the side. Squaring means to multiply it by itself. So if I write 4 square roots of 3 times 4 square roots of 3, 4 times 4 is 16. Square root of 3 times square root of 3. Now we're multiplying, so it's going to get bigger. Just like when you multiply x times x. It doesn't stay x, it becomes x squared. So square root of 3 times square root of 3 is square root of 9. But what is the square root of 9? Oh, that's 3. So this is 16 times 3, which is 48. So I'm using your algebra skills and arithmetic skills you've learned in the past. So that becomes a 48. Plus, we're going to do the same thing here. This is negative 3 square roots of 5 times negative 3 square roots of 5. Negative 3 times negative 3 would be 9. Square root of 5 times square root of 5 would be square root of 25. Remember, multiplying means it gets bigger. We know the square root of 25 is 5. 9 is a whole number. 9 times 5 is 45. Now we're going to add, because you have two numbers in a symbol, 48 and 45 add to 93. So the last question is, can you square root 93? Not, can you go in a calculator and type it in? Because I know if you type it in a calculator, it's going to give a decimal. But can you break it down? Is there a perfect square in 93? 4 doesn't divide into 93. 9 doesn't divide into 93. 16 doesn't work. 25 doesn't work. 36 doesn't work. 49 doesn't work. 64 doesn't work. 81 doesn't work. There is no perfect square in 93, So that's your answer in lowest terms. So all we learned so far is you can find the distance between 2 points. You could graph it visually and look, and if it's a horizontal line segment or a vertical line segment, no formula is needed. Just count the boxes. But if it's diagonal, you have to do the distance formula. And all the distance formula is the Pythagorean theorem. Now, let's go back to the notes. We got one more formula to look at. So if we go back to our notes and we go to our next formula, our next formula is called the midpoint formula. Now, listen to the vocabulary. Midpoint means the point in the middle. You can have a point in the middle of a line segment. I want to know where the halfway mark is. You do this all the time. If you're a little kid and you're going to meet your friend walking, you each want to walk the same amount, you each want to walk halfway. You're finding a midpoint. Okay? If you look, there is a formula down there. Now, the formula in your notes is not hard to memorize. It says x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. Again, let's think about that. Let's think about what walking in the middle means. I'm going to give you a perfect example you use all the time. You get an exam. You get on it at 80. The next week you take an exam and you get 100. What is your average in my class? Well, most of you know how to figure out your average. You take your two scores, you add them up. So if you got an 80 and you got 100, that's 180. And then you divide by 2 and you get 90. Do you agree 90 is in the middle? Yes. So that's what you're doing when you find a midpoint. You're adding and dividing. So you can think of the word midpoint as averaging. So let's go up to our whiteboard again, and let's work our last 3 examples. I'm going to take the same 3 points. Again, you don't need to always use that formula. If I draw a line segment from here to here, AB, and I want to know the point in the middle, if it's horizontal, we know from here to here was 4. So halfway would be each of us walking 2. 1, 2, 1, 2. There's the point in the middle, and that's located at 3, 1. Again, if I have a vertical line segment and I want to find the point in the middle, I don't need a formula. From here to here is 1, 2, 3. So if we're each going to work halfway, we're going to walk 1 1/2. 1 1/2. 1 1/2. So this would be the midpoint, the point in the middle, which is at 1 and negative 3 1/2. But if you have a diagonal line segment like our first example is going to be, we are at negative 4, 9 again, and at 1, negative 3 again. And again, please excuse my sketch. If I want to know where the point halfway is, well, we found the distance from here to here was 13. So we know halfway is 6 1/2. But we can't count 6 1/2 diagonally. So we have no choice but to use the formula. So let's take our 2 ordered pairs, which were negative 4, 9, and 1, negative 3. And the midpoint says, very simply, we're going to average. We're going to take our x's, add them, and divide by 2, because you can only add terms that are alike. We're going to take our y's, add them, and divide by 2. The reason why that formula is in parentheses is because we're finding an answer that's a point. And a point's got to always go in parentheses. So now we'll fill it in. Our first x value is negative 4, plus our second x value is 1, and we're going to divide that by 2. Then we're going to do our y's. Our first y is 9, plus our second y is negative 3, and we're going to divide it by 2. Now, you all know this. We've got to work what's in the numerator first. Negative 4 plus 1 is negative 3 over 2. 9 plus negative 3 is 6 over 2. Now can we divide? Well, this is an improper fraction. We could leave it as an improper fraction in lowest terms. But this improper fraction divides. 6 divided by 2 is 3. So you could write the ordered pair, the point where the midpoint is negative 3/2, 3. Or you can get your calculator and divide negative 3 by 2 and get the terminating decimal negative 1.5 and 3. What you do not write is a mixed number. We've already been through that, no mixed numbers. Now look, I drew a picture, so I'm going to check that. If I go to negative 1.5, 3, yep, that point is in the middle. So I could see that. All right, let's try our next example. Our next example is the one with the fractions. So again, I'm going to take those same two ordered pairs we found the distance of and now do the midpoint. So we have 7/3, 1/5, and 1/3, 6/5. If they want the midpoint, you're right. We got to fill in a formula because you can't use graph paper with fractions and decimals. So we'll write the first x is 7/3 plus the second x is 1/3 over 2. The first y is 1/5 plus the second y is 6/5 over 2. You got to work the numerator. To add fractions, you need an LCD. It's alike. So 7 plus 1 is 8/3 over 2. 1/5 plus 6/5 is 7/5 over 2. Now, sweethearts, you can't leave that. The definition of a fraction is one number in the numerator that's whole, one number in the denominator that's whole. Well, yeah, that's a whole number in the denominator, but this is not a whole number in the numerator. So we go back to our arithmetic skills. What does this bar mean? 8/3 divided by 2. I'm going to write it over here like I would in 5th grade. We've already learned this. You don't divide fractions. Instead, you multiply by their reciprocal. What is the reciprocal of 2? 1/2. So 8/3 times 1/2. Multiplying fractions is no problem. Top times top, bottom times bottom. To multiply, things do not have to be alike. You don't need an LCD to multiply. So you do 8, and 3 times 2 is 6. The same thing here. You cannot leave this. If you had a good fraction algebra teacher, this was called a complex fraction. You can't leave this. 7/5 divided by 2 means 7/5 times the reciprocal, or if you want to be fancy, the multiplicative inverse, which is 1/2. And then you'll get 7 times 1 is 7, 5 times 2 is 10. Now that's still not acceptable because 8/6 is improper, can be reduced. You can divide by 2 and get 4/3. This point, 4/3, 7/10 would be the midpoint, the point in the middle, if you could graph these. But again, to graph fractions is kind of hard on the graph paper because we're used to dealing with whole numbers. All right, we got one more example with the midpoint. And again, now this point's going to be with the roots, the radicals. So our last example. All right, we have the ordered pair. 3 square root of 3, square root of 5. Negative square root of 3, 4 square roots of 5. Your job is to find the point that would be located in between these. Again, I agree with you. To graph irrational numbers would be very hard on graph paper because you'd first have to convert these to decimals and then find out where they are. So guys, look at me. Anything other than whole numbers, if we're dealing with graphing, we have formulas. So to find the midpoint, it's an average. Average means to add and divide. So I'm going to take my first x, 3 square root of 3, and I'm going to add it to my second x, negative square root of 3. And I'm going to divide by 2. I'm going to take my first y, square root of 5, and add it to my second y, 4 square roots of 5, and divide it by 2. Now, I'm adding a negative 1 to a positive 3, so I'm really subtracting. So that gives me 2 square roots of 3 over 2. Again, rules are rules. You add things that are alike. You add an x to an x because the variables are alike. 1x plus 1x is 2x. The x stays the same. You add fractions that are alike. 1/4 plus 1/4 is 2/4. The denominator was the same. It stayed. So when you add radicals, you leave the radicand the way it is. 1 square root of 5 plus 4 square roots of 5 is 5 square roots of 5 over 2. Now we're going to do the dividing. Because this whole number is connected to this radical by multiplication, you can divide out the 2's. You're left with square root of 3. Over here, 5 doesn't divide by 2 evenly. you're not going to see a decimal with a radical. They'll leave it in fraction form. So this would be left as 5 over 2 square root of 5. And that point would be the midpoint of the two ordered pairs we started with. So all we found out today in Module 13 is when you plot points, they connect to make lines or part of a line, which is line segment. If you deal with a line segment, there are two words to describe it. You could find the distance between the length, and you could find the point in the middle, the midpoint. Have a good day.